Okay, there, I think it's live. Let's check. So, how about now? Okay, great. All right, let me go ahead and get started then. Got a few people, it looks like, are participating now. So, today, I wanted to start just with assignment 2, see if anybody had any questions on that. I started on that a little bit on Tuesday. We didn't talk a whole lot about it because I left it till the end. So let's start with that. I did go ahead and start with the assignment 2 here. Let me open up my assignment 2 notebook. Kind of as a reminder, the first thing you might want to check after you clone, I hope everybody's past this point and is working on stuff, and maybe if you have a question on something, let me know about the things. If you've been working on assignment 2 and are at a particular point, wanted to ask about one of these tasks or so. But yeah, when you first start up, it's always a good idea to just check that everything is running, basically, if you do like a run all the cells from the top. So if you're running in, I mentioned this a little bit last time, but I don't know if the people online on the live stream saw this. If you're running on in the web-based, if you're using the web-based Jupyter Lab, I don't think you really have a choice. If you are using the development environment that we set up for the assignments for this class, you do have to use, well, I guess there are a couple choices, but you do have to use just the basic Python 3 kernel that's on there. So if you're running the notebooks from inside of VS Code, bring up VS Code here real quick. So it's not a good idea to have the same notebook open in both places, because you might get some conflicts with them overriding each other when they save things. So I'm not going to save this, but if you are running a notebook in here, you might want to check the kernel that you're using. So, and I've got all the things installed, but so yeah, it tries to use your running Jupyter Lab, so you need that password. But I think it's actually better to use the kernel that'll come up on your Python environment, the one that's the 3.12 that's in the opt conda. So I did mention this a little bit last time. So anyway, try using that. I believe that's the one that if you're running your notebooks from VS Code, if you use that kernel, then when you save it and push it back up to GitHub, it should work. That should be the right name for the for the kernel to get everything to work. So anyway, try that out. I had at least one person was having some issues with their kernel. I don't know if anybody else has run into an issue or not, but let me know if you're seeing a problem with that. So okay, so there were a couple things I was going to mention, and I might just jump to them straight away. So let me know. The first part is about doing a linear regression, and I do ask you to fit a line. So there is one place in the notebook where you are supposed to create a figure and fit a line to it. So there's some examples of that in the lecture notebooks and the other materials. So you might want to check those out. So there's lots of different ways you could fit a line. I would prefer you to do just a basic matplotlib plot and then kind of fit it by hand. So take the fitted model, take the create some predictions for it. So the best thing to do would to actually be to create a new set of X points that just has 2 points, one at point 0, so a temperature of 0, and one at like point 25, and get your 2 predictions. So from those 2 predictions, you can create a line. So a lot of people just use the predictions of the data. So they take the data that you had read in and create the predictions, and for a line it'll look like everything works, but the problem with that is that this data is not in any particular order. So in fact, this if you do it that way, you've got a bunch of line segments that are going back and forth. So if it's on a line, you don't see a problem, but like on the next assignment, if you do that, it won't look right, because it's not we're going to be plotting a nonlinear fit for some function, so you'll get something that doesn't work. So it's better right now if the first time when you try and plot a regression line to remember this. So to generate the data and get predictions on the data. So don't use the data that you trained with, which might not be sorted. So for this one, if you're doing a line, you really just need 2 points, one at 0 and one at like 25, or whatever the begin and end range is of the line that you want to plot on there. So, yeah, I wanted to kind of talk a little bit about, there is one task. So the second part of the assignment is to do a classification. Right, so this is a typical binary classification. You're supposed to be using the rain, whether it's going to rain tomorrow, yes or no. And part of the task 2 was to encode that categorical variable. So it was like a string in the data set. You have to encode that as like a 0 or 1. So it looks something like this, and you're supposed to be using the sunshine measure, which I don't remember what the units are of that. I think we talked a little bit about that in the assignment, and the pressure. So if you fit this using both scikit-learn and stats model to do a logistic regression, which will fit a classification, you'll get what's known as a decision boundary. Okay, so if you, for this part here, we haven't talked about decision boundaries for a classification problem, or even the linear regression and what those parameters are, and how it is that you plot that line. So starting next week, that's our first thing. We're going to get into the details of linear regression. So for the first task on this assignment, you did have to output the the parameters of the fitted model. So those are the things on the first figure that you're supposed to create. Those are the things that actually determine the properties of this line. So for the linear regression, there's actually 2 properties on this assignment. There's the slope and the intercept. Okay, so I'm previewing a little bit of the stuff we'll start with on Tuesday next week. But basically, from those 2 parameters, from the intercept parameter and the other parameter, which which really represents the slope of the fitted line, since we've only got one feature, and we're trying to predict evaporation on this one here. So with those 2 parameters, you can determine what the line was that was fit on your data there. Okay? So likewise, I think I've shown this before. I don't really like scrolling back and forth like that, so I usually like to bring up my outline. So back to visualizing here. So it's similar. So when you fit a logistic regression, which is really a classification model, in this case, you're going to get 3 parameters. You're going to get one intercept parameter, and then you're going to get a parameter for each of the 2 features that you were using in the classification task. Okay, so the 2 features represent the amount that we're going to be multiplying the sunshine feature by, and then the amount that we're going to be multiplying the pressure by. And then the third one is the same as the intercept parameter for the linear regression again. So this is described here, but basically what you'll get is Hopefully everybody can follow this if you read it, but I thought I would just walk through it just to make certain everybody's clear. Again, you do need to do this one by hand. You can't plot the decision boundary here. There's other ways. We'll see some other ways to plot a decision boundary. So if you have a more complex, something that's not a linear decision boundary, you have to do something a little bit different. So somebody's asking, I think, about the linear regression. It would be a good idea if you're already finished with the assignment to, if you plotted the linear regression using the data to do your predictions, you might want to go back and try and redo it. It would be better to learn how to do that. So basically, for that one, you need to just create a new array of points, and it only needs to have 2 points in it. So x just needs 2 points, and then you make the prediction. So what would be the predicted whatever that measure is when the value is 0. I'll just go back to this since I'm talking about it here. So what would be if you have 2 points, what's the predicted evaporation when the temperature is 0, and what's the predicted evaporation when the temperature is 25? You'll be able to use that to create your line here in the same ways that we showed doing in the lecture notebooks and some other materials. All right. So, where'd I go? There it is. So for the decision boundary, it's a little bit more complex. There's actually 2 coefficients. You should do this using the information that you get from the scikit-learn logistic regression. But from scikit-learn logistic regression, you can get the I ask you to, we call it slopes when you return it back from calling here, but this should end up being an array that has 2 values, 2 coefficients. So the coefficient of the sunshine feature and the coefficient of the pressure feature. Okay. So given those 2 coefficients, really the decision boundary is this line here. Okay. So if you go back and remember some basic algebra, the equation of the equation here ends up being a line since we've only got 2 parameters. So we're using sunshine as kind of the x and pressure as the y, right? So you should get the coefficients right. So it should be the first coefficient needs to go times the sunshine, whatever your first feature is in the columns that you train your model with, but that should be sunshine. And then the second coefficient should be the one that's multiplied by pressure. So you end up with an equation like this, right? And if you solve for it, then you can figure out basically by fitting in the coefficient. I call it coefficient 0 and 1 here. So theta 0 is really the coefficient 0 and theta 1. But if you fit that in, those values, and then again, all you would need would be 2 points, a point at like 0 and 14. And that will tell you what the y value should be at 0 and 14 to get your decision boundary that you plot out here. All right. Okay, so I think that was. So let me know if anybody has any questions on that. This stuff, don't worry too much if you're not following that. Just try and plug this in. You should be able to recreate this figure, right? So if you do that right, you should get exactly the same figure for your data. There are some other things here. There are examples of doing plots like this. So for this one, probably the easiest way to do it is you really need to take your data and use a little bit of NumPy to do 2 plots. So actually you'll need to do 3 different plot commands. So do one plot where you only do the data where the label is no rain, and plot those as blue circles that we show here, and then pull out all of the data on your input that's where the label is yes, and plot those as red X's, right? And then do a third plot where you do this to determine the line that represents your decision boundary and plot a dashed line for your decision boundary. So, right, but that's usually the easiest way to do this plot here, is use a little bit of NumPy to actually make two separate plots for your no and your yes, and do the appropriate stuff to get the symbol values and the colors and things. So, right. Don't forget, do use good visualization sorts of things. So always label your axes. If you have multiple elements on a plot, you should always have a legend like this, where you're explaining the meaning of, in this case, the color and the shape of our symbols. We use both color and shape for the two different classes in our binary classification here. So, all right. Yeah, so I'm going back and forth on the linear regression. So yeah, I like I was talking about for the linear regression, they had asked, the question was about the linear regression, which is what I thought you were asking about. So yeah, when you plot this one, I do recommend that, again, hopefully everybody, from looking at the examples show how to do it the way I'm describing here as well, right? So it's not a good idea to use the data that you trained your model with to create your line. So once you fit a model, I think of the line, or for a regression model, that actually ends up being the model's fit, or the representation of what the model is going to predict. Okay, but yeah, so this data is not going to be ordered. So if you use that to do your predictions to plot this, it's really a bunch of small line segments that are going all over. So once you start trying to plot a nonlinear model, you'll see it's problematic. So not a big deal, but and I probably won't take points off as long as you get the right line here. But I will mention it to people that didn't see this or miss that. When I look at how you created this visualization here. So for the other visualization that you have to do, usually there's, again, there's also multiple ways you could approach this, but most people probably will find it easiest to use a little bit of NumPy or pandas. So pull out the values for the yes and the no based on the labels, and do separate plots for those, and then do a third one where you calculate your decision boundary and plot that as a line on there. So. All right. So going back, I know I'm a little bit late on this. I think I mentioned this on Thursday, but I mean, at a minimum, you need to at least have made a commit for task 1 and 2. I would really like to see commits separately for each one of these subtasks. If it was a little bit too late for you hearing that, that's okay. But in the future, the comment I gave on the assignment 1, was the best practice is to commit early and often. Okay, so Git is your friend. One of the ways it can help you is, if you're doing your work and you're keeping it pushed up there, if you do lose your work locally, anything you get pushed to your GitHub repository, assuming there's not something catastrophic and the Git servers blow up or something, but that is basically like saving it, a backup of your data, right? So at least 1 or 2 people that helped them on the first assignment, where they had some problems and lost some of their local work, but they'd already made some commits of their data, so they didn't lose everything, right? So one argument for committing early and often is it is kind of like backing up your data, right? So it helps you not lose stuff if you have problems on your local system when you're working on assignments and things. So the main reason why I want it, besides it's just good best practices, is this gives me a better idea of how people are doing the work, how they're approaching problems. So I can see the individual commits, and see what you're actually modifying step by step. See if you miss something and have to go back. It is fine if you find out something's not working to go back and fix it and make a commit for something like that. But in general, when you're first trying to get a task working, or in this assignment, like the subtasks, it would be a good idea. So for this one, probably each one of the, what I would have liked to have seen if I'd said this earlier, would be that each one of the functions, at least, that you're supposed to write in the assignment tasks, after you get that working and the test passing in the notebook, you should make a commit. So after you get the task 1 linear regression function working, make a commit of that, and then after you get the stats model linear regression. So that would be at least two commits for the task 1, and then some separate commits after you get the encoding working and the missing data cleaning part working for the task 2, and then also the scikit-learn and the stats model logistic regression. Since I've got this up, I thought I might mention just again, so I hope everybody's kind of past this part, but do make your commits early and often, and also check them out, make certain they are showing up on your feedback pull request, and that the stuff is passing like you're expecting and things. So for example, I won't get any of these tests to pass, but I have modified my notebook. So at this point, since I reran my notebook, it's showing up as modified. So anytime you rerun the notebook, it would show up as modified. It is okay to commit the notebook multiple times in each task whenever you make a commit. So I can check that my notebook is running cleanly up. I might be slowing down a little bit here. Shoot. Still having issues with these settings. I've been testing out stuff and just still, like for Zoom, it does seem regular after I'm running for a while that we tend to have some performance issues. Okay. Oh, it's really there. Give me a second. I'm completely non-responsive. Yeah, I lost the stream. Okay, let's restart the stream.